Hey guys, we've been talking about saving our money. Let's talk about two rules that help us consider what we're doing with our money and whether it's the right thing or not, or whether it's going to help us achieve our goals or not. The first is the rule of 72, which you should have heard about or at least discussed a little bit in Personal Finance 1. And the second is the time value of money, which really isn't a calculation at all, but instead a comparison of two pieces of information. And we'll explain the reason why when we get there. But let's start with the rule of 72. The rule of 72 is essentially just a shortcut to estimate how long it will take you to double your money at a certain interest rate. It doesn't matter the amount of money that you have. The only piece of information that you need is what the interest rate is. So the formula is that you literally take the number 72 and divide it by the interest rate in whole number percentage form. So if I have an interest rate of 12%, I divide by the number 12. I do not divide by 0.12. I use the whole number percentage. And it's important to note that this formula works best for an investment that is using simple interest or is compounding annually. It really doesn't work for any investments that compound more often than that. So let's do an example here for a second. Let's say that I have an investment that I can get, I can get 12% from. And I want to know how long it's going to take me to double my money, no matter what the amount. So if I take 72 and divide it by 12, the answer is going to be 6 years. It's going to take me 6 years to double my money. How could you put this to use? Well, let's say you're driving a car and you know that you can secure an investment that has 12%. And you can double your money in 6 years. Now you can figure out, well, okay, how much can I save in 6 years? Or how much do I need to put in an initial investment? And if I leave it sit for 6 years, what will it double to? Let's say that's, you have $2,500. Can you afford to make an initial investment of $2,500 and leave it sit for 6 years? Maybe. And then at the end of 6 years, you have $5,000 available to you to go buy a car. So that's a way that it could be useful to you. Now, let's continue with our presentation and look at another way that you can use the rule of 72. Here's our slide we just did. The other way that you can do it is to work in the reverse. Maybe you have a set number of years that you can save money for, and you have a target goal of a certain amount of money, and you need to figure out what interest rate you need in order to double your money in that set number of years. You can use the rule of 72 again in this situation. You just simply swap out the interest rate for the number of years. So let's say I want to buy a car that is worth $5,000. And I know that I have 5 years to save for it. Well, let's use our rule of 72 and calculate the interest rate that I'm going to need to double my money. I would take 72 and divide by 5 and find out that I'm going to have to find an investment that has 14.4% interest rate or better in order to double my money in my time of 5 years. Again, you can see how that could be useful to you. There are issues with the rule of 72, though. For those of you that are math minds, the rule of 72, without getting too complicated, works off of a natural logarithm that I'm not going to go into. But it's important for you guys to know that the rule of 72 works best and most accurately for interest rates that are between 5 and 10%. When your interest rates start to move outside of that window, you need to kind of work your rule of 72 on a sliding scale. So the variation is that You should adjust the rule of 72 by adding or subtracting 1 from the number 72 for every 3 points that the interest rate moves away from 8%, because 8% is the middle of that acceptable range of 6 to 10%. So if I have an interest rate of 11 to 13%, then I'm going to technically use the rule of 73. And then if I increase to the next increments of 3 points up for 14 to 16%, I'm going to really use the rule of 74. And then it works in the reverse for things that are below 8%. 3 to 5%, I'd use the rule of 71, and 1 to 2% return. So for like traditional savings accounts, I'd use the rule of 70. And you'd find that that's like 35 to 70 years to double your money, which is why savings accounts aren't really considered investments. We'll practice the rule of 72 tomorrow in class. Let's talk about the time value of money. And essentially what I can tell you about this, guys, is that the time value of money is really just evaluating the purchasing power of $1 today versus $1 in the future. And there are 2 key things that you should consider when we talk about the time value of money. You should consider the inflation rate for a particular product and the interest rate on your investment. And why, or what's the comparison? Well, if your investment does not earn enough interest to beat the inflation rate, it becomes a bad investment. And you're essentially losing money on that investment because you're not making enough to purchase what the money could purchase today in the future. It's a little bit confusing, and we're going to do some examples in class, but let me try to work you through an example here. The way that it's calculated is that you first have to figure out what the inflation rate of a product is. And that's done simply by taking the current price and subtracting out a price that you knew it existed at some point in the past, a historical price. And then you take the difference and divide it by the historical price again. That gives you the total inflation over that number of years. And then if I want to figure out the yearly inflation, I divide by the number of years difference from the current to the historical price. And that gives me its inflation rate per year. Confusing. So let's look at an example. A common example is a car. The average cost of a car today, a 4-door vehicle, is about $33,560. The average cost 20 years ago was $13,600. So if I calculate the difference, I'd get a difference of $19,960. And if I divide it by the historical price, which was the $13,600, I'd get a percentage increase of 146% over the last 20 years. So how do I figure out the yearly inflation? I'm going to take 146 and divide it by 20 and come to find out that vehicles, 4-door cars, have inflated in price at a rate of 7.3% per year. So what does this mean for me? Unless I can find an investment that makes an interest rate of more than 7.3% per year for my car, I'm going to lose purchasing power with that money I save. Meaning I could buy more with that money today than I will be able to in the future, which therefore makes that investment a bad investment. This topic's a little bit tough to talk through, and hopefully when we split into our groups and work at our stations tomorrow, you'll start to understand why considering the time value of money and considering its purchasing power is extremely important. No walk-in work for tomorrow. Just make sure that you have your reading guide completed and come with any questions. Type them into your reading guide and I'll address them to start class. Have a good night, you all.